Ever wondered how we create the integrated circuits used in data centers, smartphones, artificial intelligence, automotives, renewable energy, and medical imaging? Integrated circuits are made using materials known as semiconductors. A semiconductor's ability to conduct electricity lies between those of good electrical conductors and insulators. Crucially, engineers have also learnt how to precisely control conductivity in semiconductors. In this video, we'll show the key manufacturing stages of the integrated circuits that run virtually everything in the modern world. The starting material of an integrated circuit is a pure silicon wafer. The raw material is abundant on Earth in the form of sand, or silica. Heat is applied to purified sand in the presence of carbon to remove unwanted oxygen and produce granulated silicon crystals. A pure silicon seed crystal is dipped into hot, melted silicon. As it's slowly pulled up and rotated, silicon from the melt sticks to the seed, forming a single crystal ingot. Each ingot is sliced into thin wafers, which are carefully polished to create a smooth and flawless surface. These silicon wafers are the starting point of integrated circuit manufacturing. Using sophisticated tools, semiconductor engineers design the integrated circuits using different types of silicon: N, P, oxide, and poly. Complex patterns of these different types of silicon make up the integrated circuits. For instance, this circuit will invert a signal, turning 1 into 0 and 0 into 1. The circuit design is then translated into a set of photomasks, crucial for the manufacturing of actual integrated circuits later. Because integrated circuits are so small, manufacturing must take place in a clean room, a highly controlled environment, to minimize contaminants. Oxidation is an important stage of semiconductor production. Adding oxygen to the silicon wafer surface creates silicon oxide. A special light-sensitive material called a photoresist is applied to the wafer. In a process called photolithography, a photomask is then placed on the wafer like a stencil. When the wafer is then exposed to UV light, the photoresist changes chemically and can be washed away. Photolithography transfers the photomask's pattern onto the photoresist, which now only cover parts of the wafer. According to the circuit design, we add a very small amount of charged particles to produce the different types of silicon on the exposed parts of the wafer. These create the N or P-type silicon. Etching removes unwanted silicon from the exposed parts. Many iterations of photolithography, ion implantation, and etching are repeated using different photomasks to build up the integrated circuits, one photomask at a time. Metal connections are also added to form paths for electrical currents according to the circuit design. Electrical testing checks if the completed integrated circuits meet quality control. To package the individual integrated circuits for easier handling, they're cut from the wafer and attached to a suitable base. Metal wires are bonded to metal contacts before encapsulation, which protects the integrated circuits from contaminants and the elements. From grains of sand to intricate integrated circuits, semiconductor manufacturers use highly complex processes to produce the most essential technology in modern society. Next time you use a smartphone, car, or any electronic gadget, remember that it all started with sand.